Alright, so if we just look at the picture we're given and have a look at tan alpha in the right angle triangle here, so their old age, and look at tan beta, actually, and make h the subject, so that would be 100 plus x tan alphas equals h. Now look at tan beta, their old age, and make h the subject, and you've got x tan beta. They're both equal to h, so let's make them equal to each other, and then we'll have x tan beta equaling 100 plus x tan alpha. So if I make x, this part x the subject, I'm going to get, and I'm also, okay, so that gives you that. And actually, if I then break this up and divide by tan beta, that is what I'm going to differentiate when I do dx to t. But just before I do that, let's have a look at this part. Use part A to find the value of x and the height of the plane when alpha. So if we think of alpha as pi on 6 and beta as pi on 4, well, let's sub that in. So we're going to get, if I go back to, I might do it in here actually. So if I go to here, I would get 100. 10, where's my alpha? 10, where am I looking here? Alright, so that's tan 30, which we know is 1 on root 3, over tan 45, which is 1, so I won't put that one, plus x, and this will be again tan 30, so I've got 1 on root 3. So if I make, well, I've got 1 on root 3, 100 plus x there. So actually, if I put all the x's together, I'm going to go over here. I'm going to have root 3x, if I just times that by root 3x, then minus an x, and that's going to equal 100. So you can see that 3 minus 1 equals 100. I think I went the long way. Alright, so I get x equaling that, and if you want to rationalize, let's do that. So let's rationalize, and we'll get 100 lots of root 3 plus 1s divided by, difference 2 squares here would be 3 minus 1, which is 2, so we're going to get 50 root 3 plus 1. Alright, so just remember that x is equal to that, and then the other thing is, if I put that in there as well, tan beta is 1. So 1 is also h on x, so you can see from that that x is equal to h. So not only is this x, but it's also h. So let's keep that handy. So we'll rub that bit off. I'm going to rub that bit off. And just remember this bit. So maybe I'll write that bit up here. So we know that x equals h equals 50 root 3 plus 1 there. So actually maybe, no, okay. Alright, so knowing that, let's now differentiate. So let's do dx to t. We can do it straight away if we do implicit differentiation. So looking, I'm using this here, and I've just got to be a little bit careful. Alright, let's try it. So when I do dx to t on that first term, so I've split them in two, you don't need to, but I decided to do that. So if I differentiate the top, I get 100, so tan would go to sec squared alpha, and then remember alpha is in terms of t as well, so it's like the chain rule. So then I'm timesing by alpha, d alpha to t, we can call that alpha dot. And then I'm timesing, that's u dash times v, v being the bottom, minus, alright, now differentiate the bottom, so there is sec squared beta, and b is in terms of t, so times b dot, that's using the chain rule, times u, the top, so times 100 10 alpha, and that's all over 10 squared beta, the square of the bottom. Alright, I'm going to run out of room totally here. So then I've got, so that was just for this term, the first term. Now I'm doing this second part. Now the second part has a product rule on the top, and it is also a quotient rule. So we need a product rule and a quotient rule. So actually I'm going to write it down here. So plus. So I'm going to differentiate the x, so that's dx to t, or x dot. So that's u dash v, so this is the product rule first, plus v dash, so v dash times x, so v dash is the sec squared alpha times the alpha dot. Alright, all that, so that's the derivative of the top times the bottom, minus, and remember all this is going to be on tan squared beta as well, minus the derivative of the bottom, which is sec squared beta times beta dot, because beta is in terms of x, times the top, so times x tan alpha. Alright, now I'll get rid of that. So that's just implicitly differentiating. Okay, so first of all, if I look at this, yes, alright. So if I look at this first term, if I was just looking at this bit here, the tan, this would cancel, and you're just going to get 100 sec squared alpha times alpha dot, and same with sec squared alpha is this bit here. If you think of this bit and that bit would cancel there, you would get plus x sec squared alpha. So it's the same thing, but it's 100, so I'm just going to write 100 plus x, lots of those. Can you see that? So that's 100 plus x, lots of, I'll put the alpha dot first, that's alpha dot and sec squared alpha, and that would just be on tan beta. So it's like I've covered that section and this section. Alright, and then if I now look at this section with sec squared betas, this has sec squared betas in it too. So here I'm going to get minus, there's going to be 100 plus x, lots of sec squared betas times b dot tan alpha. And this is on tan squared beta. And then the last bit is kind of this bit, remember it's times by tan beta on tan squared beta. So, oh yeah, so I can cross that off. So it's just positive dx to t, and then we've got tan alpha on tan beta. Alright, sorry, it is a mess. There is a lot there. Alright, and from what we did before, hopefully you've still got that written somewhere. Remember that this section, 100 plus x lots of tan alpha, this is from the beginning, that bit, we know that's equal to x tan beta. So if we were to rewrite that as x tan beta, and now we can divide that by one of those. So we're going to have x beta dot sec squared beta on tan beta. So everything now, all the fractions are on tan beta, so I'm going to put tan beta on the other side. So I'm doing dx to t on the other side. So now I've got dx to t, if I multiply through, I've got dx to t tan beta, and that gets rid of, you know, all these. And now I've also got dx to t tan alpha, so if I factorize, I'm minusing tan alpha on the other side. So that gets rid of that term. Now, what have we got left? So we've still got this first term, so we've got 100 plus x alpha dot sec squared alpha minus, and remember here we've got b dot x squared beta, and this is times x. Don't forget that x there. I'll just put it here for a second. All right, so then if I just want dx to t, I'm going to take that 100 plus x alpha dot sec squared alpha minus that b dot x sec squared beta and divide it by 10 beta minus 10 alpha. I think that gives us what they asked for up here. So this is what we're heading towards. So we got that. All right, so it's a bit of work, but we got there. So let's just go back so we can see the question. I'll go back up here and make some room. So now, if we look at the last part, if we use the angles that we've already got, so if we use here a dot is going to equal this, b dot is going to equal this, alpha equals that, beta equals that, and don't forget x, which equals h, equals 50 root 3 plus 1. We already found that out. So we're going to use all that and sub into this equation here. So we're going to get dx to t is equal to, all right, so we've got alpha dot, which is our 5 on 36, root 3 minus 1. Then we're timesing by x is 50, root 3 plus 1, plus 100. Lots of sec squared alpha. Sec squared alpha, so cos of, what's alpha? Cos 30, we know is root 3 on 2, so tip that upside down, you've got 2 on root 3, square that, you've got 4 on 3. Minus b dot, which is 5 on 18, root 3 minus 1, times x, which is 50 root 3 plus 1, times sec squared beta, so cos of pi on 4, cos 45 is 1 on root 2, tip that upside down, we've got root 2 on 1, square that, you've got 2. And all that is on 10 of 45, which is 1, minus 10 of 30, which is 1 on root 3. Alright, so I'd just say, might as well just put all that in your calculator now and approximate. You should get minus 55.6 kilometers per hour. So the speed, we're only after speed, not direction, so therefore the speed of the plane is 55.6 kilometers per hour.